All right, transformers. In fact, yesterday when you were getting the exam about the chapter 6, section 2, there was a question. Mutual inductance. Which of the following device works on the principle of mutual inductance? It is transformers. Why transformers? Because transformers have two coils like this. One coil is primary coil on the left side, secondary coil on the right side. So when you change the electric current on the primary coil, alternating current, so then you change the magnetic flux through the secondary coil here, and then you got induced EMF on the secondary coil. That's why we say that transformers are constructed on the principle of mutual inductance. Transformers are constructed on the principle of mutual inductance. So this is a device. Transformers are a very important device which is used to change a smaller AC EMF to a higher one, or a higher AC EMF to a lower one. This is second one is very popular. We are using this in our houses. For example, your cell phone charger needs 1.5 volt, but if you attach this cell phone to 220, so it's going to burn. That's why we should first change this 220 volt, which is higher AC, to a lower one, which is 1.5. So by using what device? Transformers. Transformers are used to that in our life. My computer works with 9 volt. So then 220 volt must be converted to 9 volt by a transformer. So if a transformer converts a higher EMF to a lower one, which is known as step down, it's going down. EMF is going down, step down transformers. These are very popular in our life. Many devices you are using at home, or I mean in life, works with the ACMF, which is less than 220, and then that's why we use transformers. But the first one is a smaller ACMF is converted to a higher one. This is not so much in our life. A few applications possible, smaller. Sometimes we need smaller, higher EMF. Than smaller one. These are called step-up transformers. Why? Because the potential difference and then this ACMF, AC potential difference, is converted to a higher one. That's why it's called a step-up, greater transformers. So how is it possible? How a transformer can do that? So we change the by arranging the number of loops in the primary and secondary coil. We can do that. Yani you can make a transformer step up, or you can make a transformer step down, depending on the number of turns in the primary and secondary coil, by arranging number of loops in primary and number of loops in the secondary. So as you see, they are different here. Here in number of loops in the primary is greater than the number of loops in the secondary. So by making this number of loops, it's possible to construct a step-up transformer or a step-down transformer. So how is it possible? We know that potential difference is directly proportional to the number of turns. This is in fact a Faraday's law of electromagnetic induction. Maybe you remember. E is equal to negative delta phi over delta t multiplied by n. N. E is proportional to n. Potential difference is proportional to number of turns. As you see, V2 is a secondary potential difference. Output also, it's sometimes called output potential difference. V1 is the primary potential difference, sometimes called input potential difference. So this V2 over V1 is directly proportional to N2 over N1. Yani if number of turns on the secondary is greater, potential difference of the secondary will be greater. If number of turns in primary is smaller, potential difference in primary will be smaller. So then potential difference and number of turns are directly proportional. Don't forget this. Potential difference and the coil, it can be primary or secondary, directly proportional to number of turns. Then I can say that which coil has a greater number of turns, it will have a greater potential difference. So the coil with a greater number of turns will have a greater potential difference. And this V2 over V1 is equal to N2 over N is known as transformer equation. This is so simple. We are going to use this equation for calculating the number potential difference in the secondary coil or potential difference in the primary coil depending on the number of turns. But how transformer does this? Um, this is a generator sign. You see that this generator is attached to the primary coil. Generator always attached to primary coil. Don't forget this. Sometimes student, you are reading some chapter review questions and then asking me, yes, if we are talking about the generator attached to somewhere, that is going to be primary coil. And we are going to attach our devices. It can be a computer, it can be a cell phone, it can be some other things. Now I don't remember the names. Those things are attached to secondary coil. All they are connected to secondary coil. And because this is an alternating potential difference, alternating potential difference is what? Changing by time, which means magnetic flux, magnetic field produced by the primary coil is changing by time. If this magnetic field is changing by time, this magnetic field circulates through the soft iron core. That's why we are using iron core. Remember, iron has a material with the greatest magnetic permeability, which causes all the magnetic field lines provided by N1 coil, first coil, to also pass through the secondary coil, and that's why magnetic flux through the secondary coil will be maximum. So that's why we are using the soft iron core, which guides magnetic field. So all magnetic field lines pass through the coils. Yani magnetic field produced by the primary coil passing through the secondary coil, so produces a maximum magnetic flux on the secondary coil. If the magnetic field in the primary coil is continuously changing, which means magnetic flux on the secondary coil also continuously changing. And what happens if magnetic flux through a coil changes? Of course, there will be an EMF induced. That EMF is known as output EMF or output potential difference and represented by V2. So then I say that a CMF V1 in the primary coil causes a change in magnetic flux on the secondary coil. The change in magnetic flux induces an EMF V2 in the secondary coil, and we got this equation, which is V2 over V1 is proportional to N2 over N1. And this V2 over V1 or N2 over N1 is given a name. It is called conversion ratio of this transformer. Sometimes they can ask you conversion ratio in terms of number of turns, which is N2 over N1. Sometimes they can ask you the conversion ratio in terms of potential differences, ratio of potential differences, which is V2 over V1. So this is the basic of transformers. The first slide. Now I am going to stop right now, and you are going to ask me questions about only this page. Only this page. Any questions?
Teacher, do we need to know when it's a step up or step down? Like how?
Yes, of course. Step up transformer is used to increase the potential difference from smaller to higher, and step down is from higher to slower. Why is it used for? I'm going to talk about a few information about that. That's enough, not more than that. Some when we continue, I'm going to explain about this. What else? I will continue with the next slide. Okay. So no real transformer can transfer all the power in primary coil to the secondary coil. Yani in reality, it is impossible. You are giving energy, you are giving power to the primary coil, but you cannot get the same power from secondary coil in normal life, in real life. So some power, some energy is lost. Why? Remember, there is soft iron core, huh? Soft iron core. Do you remember eddy currents? If magnetic flux through a metal object or conductor is changing, so there is an induced current. That induced current is called eddy current. It's a current. If a current flows through a conductor, so this conductor heats up. Yani induced current in the soft iron core causes this core to heat up. What does heating up mean? So energy, electrical energy is converted to heat. Not only the soft iron core, also coils. Those coils are converting some of the electrical energy to heat. Because of these two lost energy, I'm going to say lost energy because we don't want to heat a transformer to our room. This is not what we want. This is a lost energy. Because of these two lost energy is lost, electrical energy is lost, and you cannot transfer 100% of the power from primary to secondary. This is impossible in real transformers. However, we are not going to think this part when we are making calculations. Only know that no real transformer can transfer all the power from primary coil to secondary coil. There are two causes for them. These two causes are important. One of them is induced current in the soft iron core, which is eddy currents, known as eddy currents too. And second one is because every coil has a conductor wires, and every wire has a resistance, and then that's why these wires will heat up. These two will cause energy transfer efficiency to be lower. For that reason, we say that the efficiency of the transformer cannot be 100%. It changes from 90% to 99%. Should you know this number? This is written in your book like this: from 90% to 99%, no 100%. 99 is even not possible, but it's in your book. Maybe most probably 90%, 92%, the transformer can transfer the power from primary to secondary coil. But when we are making calculation, we will think the ideal. We are not going to think real, because real makes our calculation really difficult. So then they want you to make easy calculations. We are going to assume the transform is ideal, and power in the primary coil completely transferred to the power as the secondary coil, so they are equal. Yani input power of the primary coil and output power of the secondary coil are going to be equal. What is power equation in terms of electric current and potential difference? We know that proof vardı, proof. Okay, so for input power input is I1 over times V1. I1 is electric current in primary coil. V1 is potential difference of primary coil, which is input power. And output power, I2 times V2, which is current in the secondary coil, multiplied by potential difference in the secondary coil. That's why these two powers are going to be equal to each other. We will make them equal. We are not going to make a calculation about the equivalence, but we know that this part is important for us, this output part. Why? Because input power for the transformer is constant, because it's coming from a generator. Every generator has a specific power. You can increase it, but generally we don't do that. And in the questions, we don't do that in this section. That's why this input power always will be constant. That's why, which is equal to output power. However, I and V, yani I2 and V2 are inversely proportional, because this is constant. If V2 increases, I2 will decrease. If V2 is increased, I2 is decreases. So I1 V1, which is constant, if you increase the potential difference in the secondary coil, which means you are going to decrease electric current in the secondary coil. Yes, because I and V are of each coil are inversely proportional, a transformer can step up potential difference. What does it mean? Potential difference is increasing, so electric current will decrease. Decrease in electric current is expressed as steps down electric current. Yani if a transformer steps up, increases potential difference, it's going to step down, yani decrease electric current. Or opposite, if a transformer steps down the potential difference, it's going to step up the electric current. Inversely proportional, because I and V are inversely proportional. Evet, burada da duracağım. Şimdi sorulara. Do we have a step-up transformer in our life? Yes, we have. Car ignition system. You start your car by switching. Inside the body of your car, there is a potential difference, a battery whose potential difference is 12 volts. 12 volt DC potential difference is used. But this 12 volt cannot start a car. How? First, let me talk about how a car starts. Normally, it's a kind of, maybe you said in chemistry, you are burning the fuel. Fuel is burned. But you should start the burning. How? How can you start burning? Do you know that when sometimes lightning, very strong lightning falls onto a bush or some trees, then this tree starts burning, huh? It is similar. You are making a kind of lightning inside inside the engine of your car, which is called spark. But this spark can be produced only with potential difference, which is almost 20,000 volt, 30,000 volt, 100,000 volt, which means you need a very, 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 very big potential difference to start your car. So how can you get a very, very, very big potential difference? By using step-up transformer or step-down transformer? Of course, step-up transformer. That's why in car ignition system, we use a step-up transformer to increase this 20 volt to a potential difference, which is about 20,000 volt, 30,000 volt. When you switch on your car once, as soon as you switch it, this 12 volt converts to 20 volt, 20,000 volt potential difference, and causes a spark inside the fuel of the car engine and causes the fuel to start burning. That's why if somebody asks you, maybe it's ask, I don't remember exactly, but what kind of transformer is used in car ignition system, electronic ignition system of a car? It's a step-up transformer. Don't forget this. Okay, about this slide, any questions? Yes, Sima. Yine mi ben sizi şey yaptım, unmute yaptım yoksa? Galiba ben screen share'e başlayınca o unmute oluyor directly. Benim suçum değil bu. Ayarlarla ilgili bu. It's about the... Allah'ım yarabbim. Subhanallah. Okay, unmute all. Yes, Sima, ask your question.
In the book, it talks a lot about crank angle sensor and crankshaft. Are they not important?
No, this is about you are not going to be a car. I'm an engineer. It's about how cars. Just this is enough for physics, okay?
Okay. Okay.
And any more questions?
Teacher,
Yeah.
in the book there is a question that the transformer step down and take the ratio reverse way.
But this it's not asking you the conversion ratio. Dikkat et, o soruda conversion ratio sorulmuyor. Asking you what is the ratio of V1 over V2? Olabilir, böyle sorabilir ya da N1 over N2. It's possible they can ask this question, but not asking conversion ratio, that question. Evet, başka soru var mı?
Hocam.
Yeah.
Hocam, for the ratio of V2 over V1 for step-up transformer.
Yeah.
It's greater than 1, and what about the ratio of I1 over I2?
It is less than 1. Very good. It's less than 1.
Reversely?
Yes, inversely. If V1 over if V2 over V1 is greater than 1, which I2 over I1 must be less than 1.
No, I1 over I2. What about I1 over I2?
Şöyle yapalım. Ratio, şimdi bir tane gidelim. We are talking about the conversion ratio, okay? Which is V2 over V1. For step-up transformer, V2 over V1 is greater than 1. So I2 over I1 must be less than 1.
Okay, thank you, teacher.
Başka? Sanırım yok. About transformers, there are some questions. These questions are not so hard. You can try on your own. Even I solved them in those videos in the YouTube, so then you can also